Okay, now we're going to look at the graphs of f of x equals 1 over x and f of x equals 1 over x squared and compare. So we could graph these in our calculator, and you would see that these are how the graphs compare. So what's going on? So take like 30 seconds or so and discuss with someone sitting next to you what is different about 1 over x and 1 over x squared, and come up with something that is going on, some attribute you can talk about. So 30 seconds. Okay, hopefully you noticed that the x values in, or the y values, sorry, the y values in 1 over x squared are actually all positive. This 1 over x squared graph never goes below the x-axis, making all of the y values positive, which hopefully makes sense to you because as you plug in values for x in 1 over x squared, x squaring anything is going to give you a positive value. So now we're going to do our same parent function for 1 over x squared. So once again, kind of ignore the word function booklet, but we just need to have a place where you can go back and reference the parent function. So our equation here is going to be f of x is equal to 1 over x squared. So we're talking about 1 over x squared instead of 1 over x. And this is the only other parent function we're going to talk about today. So our domain here, if you looked at the graph on the page before, which we'll graph those again, so this point goes through -1, +1, and +1, +1, and we could plug in more numbers to get it, but it's shooting up right there and starts out really steep and goes lower. So our asymptotes on here are the x and y axis as well. So we still can't divide by 0, and we'll never get a 0 if we have a 1 in our numerator. So those are still our asymptotes. The domain is going to be all real numbers. If you look at this graph from left to right, it's all real numbers except for 0. So our domain would be all real numbers, except x cannot be equal to 0, or you could go -infinity to 0 with a parenthesis, and then 0 to infinity. Our range, if we're coming out from the bottom of our graph, our range starts at 0, but it's not touching 0. It starts right after 0. So this would be an example when our range starts at 0 with a parenthesis and then goes to infinity. And then as we look from left to right, it is increasing from -infinity to 0. Those values are all increasing, and then right after 0, it starts decreasing, so it is decreasing from 0 to +infinity. Our left end behavior, so as we look to the left, our graph is approaching 0. So the limit as x approaches -infinity of f of x would be equal to 0. And the limit as x approaches +infinity, sorry, that's not your bell, of f of x would also be equal to 0, because as we go to the right, this graph is approaching 0 on our y values. So remember, with limits, we're moving in the x and y, or the x direction, either left or right, and we're seeing where our y value is. So that 0 is representing where our graph is approaching on the y-axis. So on even, odd, or neither, if we folded this on the x and y-axis, that would make it odd, which in this case, it does not give us the same graph. However, if we just fold it on the y-axis, which was the only requirement for an even function, it does give you the same value. So this is an even function, which, if you notice, it has an even power, x squared, which maybe has something to do with it. So the x-intercepts, y-intercepts, maximum, minimum, all do not exist. Is this function 1-to-1? So does it pass our horizontal and vertical line test? That answer would be no, it does not pass the horizontal line test. So It is not a one-to-one function. And does it have any asymptotes or discontinuities? Yes, it does. It has the same ones as the 1 over x function does. So x cannot be, x equals 0 and y equals 0 are both asymptotes in this case. And our asymptote behavior, once again, we are finding the limit as x is approaching 0 from the right, which would be the positive right there, and you have to put that positive or negative there to know which way you're coming from. So as we approach it from the right, so as we'll look at this purple line here, as I'm approaching 0 from the right, that graph that I just pointed to is shooting up. It's going to positive infinity. So this is equal to positive infinity. And then the limit of f of x, as x approaches 0 from the left, so as we're coming to 0 from the left, that part of our graph is also going to positive infinity. So this is also equal to positive infinity. So those are our asymptote behavior, which is similar to end behavior, but it's approaching a specific value rather than positive or negative infinity. So what we're going to do next is you should pause the video and go ahead and complete the following slides in your notes packet together. So you should do it working with just a partner is probably good. So you're going to look at the following graphs and figure out what is changing, how they've moved, write the transformations, and then as you go on, you will sketch and analyze the graph. So you probably will take the rest of the time, well, not the rest of the time, but probably a good 15, 20, I don't know, maybe even 30 minutes. But I'm going to go ahead and fill all this out right now so you can hit play on the on the video and see if you have any questions so you can get it all filled out. Yeah, so I'm going to go pretty quickly through the rest of this, so feel free to pause right now and then hit play whenever you're ready. So, as we are looking at the following graphs, and the parent function from your function booklet, well, not from your function booklet, from your previous slides, we're just going to answer the following questions. So, if you notice, if you look at the point, the point where it turns, that's our point of distinction. That's what we're kind of seeing where they moved. You can either look there, or you can look at the asymptote. So the asymptote is right here on this one, and right here on this one, and it usually is on y and x equals 0, but these have shifted. So this has gone left 3, and this one has gone to the right 2. So, similar as every transformation we've done, the x's are lying, it's shifting the graph left to right when your x's are inside your function. Then if we're adding 2 on the outside of our function and we're subtracting 4 on the outside of our function, if you notice that is moving our horizontal asymptote to be up 2 in that case, and in this case it would be down 2, or down 4. So up 2 and down 4. And the next ones are a little bit more complex. They have a horizontal and a vertical shift. So based off either the equation or just looking at the graph, this one is going to the right 3 and down 4. And this graph is going right 3 and up 3. So then if you look at the negative 1 over x squared, and you could graph these on your calculator as well to see, this is a reflection over the x-axis, so which is what happened with every other negative that we deal with transformations. And then on the second one, it is doing a couple different things. So it is reflecting over the x-axis. It is and it is moving up left 3 and up 2. Okay, these are for the squared functions, 1 over x squared, which actually is very similar things happen. So this is going right 3, up 2. This one is flipping over the x and going up 3. And now you're gonna kind of work around for these next 4. So we are sketching and analyzing the graph. So it is flipping over the x-axis. It is moving up 3, which is convenient, I guess. So I'm going to sketch that graph first. So I'm going to sketch the asymptotes because I think that makes it easier. So asymptote y on the y-axis doesn't change. This is still the asymptote. We haven't shifted to the left or right at all. But we have shifted up 3, so our usual asymptote on the x-axis is now up 3. And then we've been reflected over the x-axis because of the negative, so instead of it being in the top right of that, it's going to be in the top left and go through that point and this point. So make sure you have that point like noted or memorized for the parent function. And it shoots up like that and comes up and over like this. So I'm going to go quickly because I only have a couple minutes left before I need to shut this off. So domain is everything except for x equals 0, so all real numbers except non-x equals 0. Range is the same thing. Your vertical asymptote would be x cannot be equal to 0, or sorry, not cannot be equal to 0, but x is equal to 0. That's the line that we're dealing with. And your horizontal asymptote would be y equals 3 because it has shifted up 3. It is increasing from negative infinity to 0, and then again from 0 to infinity. So it's everywhere except for 0. It's never decreasing. And the end behavior would be the limit of f of x as x approaches negative infinity. So as we go to the left, our graph is approaching 3 instead of 0. And the limit of f of x as x approaches infinity, positive infinity, would also be 3. And then the asymptote behavior is going to be the limit of f of x as x approaches 0 from the right. So as we're coming from the right, it is going to negative infinity. And the limit of f of x as x approaches 0 from the left is positive infinity. Cool. So then this next graph is a squared function. So it is shifting to the left 3 and up 1. So our asymptotes shift to the left 3 and up 1. And our new graph, since this is a squared one, will look like this. So we would have a point here and a point here, and should look like that. So it's going to have very similar features as its parent function, but including the shifts. So the domain is all real numbers, except x cannot be equal to negative 3. The range is from 1 to infinity. The vertical asymptote would be x is equal to negative 3. Horizontal asymptote is y is equal to 1. It's increasing from negative infinity to negative 3, decreasing from negative 3 to infinity. And the end behavior, limit of f of x as x approaches negative infinity is equal to 1. And the limit of f of x as x approaches positive infinity is also equal to 1. The asymptote behavior, the limit of f of x as x approaches, this time instead of approaching 3, we're going to be approaching the asymptote. So we're approaching negative 3 from the left is equal to infinity. And the limit of f of x as x approaches still negative 3, but this time from the right, is equal to positive infinity. It's going up both ways. Based on